This is the USB-AX mixed signal oscilloscope. It has a logic analyzer and an oscilloscope function, which are time synchronized. Currently there is no pod connected, and you will see that there is a red indicator, and it's also running in demo mode. Once we plug the pod in, you'll see that the light turns green, and that it actually shows the pod ID, which is on the back of the pod. If there's more than one pod plugged into a computer, this list box shows all the pod IDs, and you can choose which one you're controlling via this drop-down list box. The intent of this application is to show the samples of one analog channel and 8 digital channels time synchronized on the screen so that you can compare and debug your application. What we're going to do is we're going to simply press the run button. We have one sine wave attached to channel 1. We also have 2 digital wires attached to a periodic sample, and the trace is finished. You see the stop condition here, and the wave is now captured. We are actually zoomed out. We're at 2 microseconds per division. If we zoom all the way out to farther, we see that the waves are captured, and that the data, if we zoom all the way out, is displayed in this window. The screen can be scrolled by clicking and dragging, clicking and double-clicking on the window. With the left button zooms in, and on the right button zooms out. And you can actually move around the screen very easily with this mechanism. You can actually go in and see what happened exactly, digital time versus analog time, as they are time synchronized to the sample. The knobs here will let you change the vertical volts per division as well as the horizontal seconds per division. You can change the physical placement of the analog signal by simply dragging the sample around. It changes the offset in case the signal is higher or lower than the screen. You can also place cursors on the screen using the gray cursor bars. There's a cursor bar here for time and a cursor bar here for voltage. You use the left mouse button to place the X1 cursor, the right mouse button to place the X2 cursor, and similarly with the Y cursors, the left mouse button and the right mouse button. Once the cursors are placed, you can use the measurement windows down here and see the physical placement of those measurements relative to the trigger position, as well as the time between the X cursors and Y cursors as well. You also see some of the automatic measurements that are taken on this particular sample. This buffer has been taken here at 16 megasamples per second, and we just so happen to have 16 megasamples in this particular buffer. So you will see that the duration of the entire occurrence was 1 second from beginning to end. The trigger position can be specified either on an analog level or on a combination of the digital levels. For an analog level, if you want to have the position of the trigger occur on the rising edge at a particular voltage level, we will set the voltage level to a particular position, set the rising edge, and when we run the capture, you'll see that the trigger position which is returned comes back and is actually at the rising edge. The falling edge does the same thing. Let's do that. The analog level and the digital trigger level cannot be used at the same time, so if you want to capture on the trigger level, you need to turn off the analog trigger. And you can specify that you want to see a falling edge, a high followed by a low of the signal 0, and this will trigger on a particular digital event. In this case, you see that the signal went from high to low, therefore triggering. Thank you for using USB-AX mixed signal oscilloscope. If you have more questions, there's a lot more features. You can read the USB-AX user's manual, which is in your program files USB-AX directory. And if you still have more questions after that, please feel free to contact us at support@usbe.